This video will be about antiderivatives from chapter 4.1. Okay, so to start off, if we're asked which function has a derivative of 6x to the fifth, we can start, for this one it would say f of x equals x to the sixth, so we can say d over dx x to the sixth. Well, that would equal 6x to the fifth. So that's right. X to the sixth minus 14. Well, you'd write d over dx x to the sixth minus 14, and that would also equal 6x to the fifth. So that's also right. And 6x or x to the sixth plus 204. Again, d over dx x to the sixth plus 204. Well, again, that is equal to 6x to the fifth. So as you can see, all of these have a derivative of 6x to the fifth, no matter what the constant is. So here are just a couple of theorems. So first you have the definition of an antiderivative. So a function f is an antiderivative of f on an interval I if f prime of x equals f of x for all the x in interval I. So that's just the definition of the antiderivative. Now, representation of antiderivatives. If f is an antiderivative of f on the interval I, then g is an antiderivative of f on the interval I if and only if g is of the form g equals f of x plus c for all of x in I, where c is a constant. So we have this, and you always have to make sure that you add the plus c as a constant, because that's very important. So over here we have, it says solve the differential equation. So we can solve it by saying d over dx of y equals 3x squared. So y equals x cubed plus c. And then we can check this to make sure our work is correct. So to check, we have d over dx, y equals d over dx x cubed plus c. And this equals 3x squared. So that's what we had originally up here, so that is correct. Now over here we have the basic integration rules, and these are just a few of them that you have to know. So this, if you say d over dx of x of n, that would equal n to the x, n times x to the n minus 1. So that would be the differential. And the integration will have the integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c. And you always have to make sure that you that n doesn't equal 1 in this case. And this is just the generalized power rule. So here, if we're asked to integrate these, we can start, for this one, we can start by saying this would equal 15. You can take the constant out, x dx, and this would equal 15 x to the 14 over 14, and then plus c. So you'd always add the plus c. Then to check, you'd have d over dx 15x to the 14 over 14 plus c, and that would equal 15 over 14 times 14 times 14x and this would cancel, so that would equal 15x. So that is correct. For the second one, we have the integral of 4 cosine x dx. So we can write, take the constant out, cosine x dx equals 4 the integral, and this would be sine sorry, don't need the sign anymore. It'd be 4 sine x plus c. And then to check, we would have d over dx, 4 sine x plus c. And that would leave us with 4 times cosine x, which is 4 cosine x. So that's also correct. And then over to our last one, we'll have, so the cube root of x dx. So it would be easier to simplify this. So we can write the integral of x to the 1/3 dx, because it's just easier to do it that way with the fraction instead of the root sign. So this would be x to the 1/3 plus 1, because you add 1, over 1/3 plus 1 plus c. You make sure you remember to have the plus c, because that's very important. So to simplify this, it'd be x to the 4/3 over 4/3 and still plus c. So that would equal 3/4 x to the 4/3 plus c. And then, once again, make sure you check your work. So d over dx, 3/4 x to the 4/3 plus c. That's equal to 3/4 times 4/3 x to the 1/3, and those cancel, and you're just left with x to the 1/3, or the cube root of x. Oops, sorry. And we've checked our work. That's the end of this video. Thanks for watching.